In this video, we're going to talk about mixture problems. So like if I have two mixtures of the same thing, but they have different percents of that. So in this example, first example is going to be antifreeze. Okay, if I mix them together, what can that tell me about the mixture in the end? Or how much of each do I need in order to come up with a certain mixture I need in the end? Okay, so I looked online and I found that if you're in a climate where the temperature drops below 32 degrees Fahrenheit for long periods of time, and that in your antifreeze that you should have a mixture that's 70% antifreeze and 30% water. Okay, so just as an introduction to how all this works, if a radiator holds 285 gallons of coolant, how much of this is going to be antifreeze? Okay, so you can remember it's 70% antifreeze and there's 285 gallons of coolant. In this case, I don't really care about the amount of water because I'm asking you how much of this is antifreeze. So in order to do this, really all I need to do is take the percentage, multiply it by how much I have, and then that tells me how many gallons of antifreeze I have. Okay, so for a much simpler example, let's say I had 100 gallons of a mixture that I put in my radiator, and it was 70% antifreeze, you would say, oh, 70 gallons is antifreeze and 30 gallons is water. So this is the same idea, the numbers just aren't quite as nice. Okay, so here's your question. Okay, so casting weighs 875 kilograms and is made of a brass that contains 87.5% copper. How many kilograms of copper are in the casting? Okay, so at this point, you'll be able to answer that question in MOMS. So just on the left-hand side, it should automatically go to the next question. Okay, now you had a chance to answer that question, okay, and hopefully you see that it's the exact same thing. So all I need to do is just say that it's the percentage, so 0.875 times the 875 kilograms, okay, and then that'll give you your percentage. 765.625, and that would be kilograms. Okay, so my next question here, okay, you need a 15% acid solution for a certain test, but your supplier only ships a 10% solution and a 30% solution. So rather than pay the hefty surcharge to make the supplier make a 15% solution, you mix the 10% and the 30% solution to make your own 15% solution. Okay, and in the end, I need to have 10 liters of this 15% solution. So how many liters of each, the 10 and the 30, should I be using? Okay, so now this is the idea. I have two things. I'm going to be mixing them together to get a third one. Okay, so I use barrels in order to do this because I just find it's the easiest way to do it. Okay, so actually if you think of each barrel as the things you're mixing together, what you're going to end up with. So you see I have these two mixtures. This is what I'm starting with, the 10% and the 30%, and they need to come out with a 15%. Okay, so I put on the barrel like what the percent of each one is, okay, and then how many liters I need in the end. Okay, so actually if you reread the problem, it says you need a 15% acid solution for a certain test. Okay, this is what you need. So that's the reason it's over here on this side of the equal sign. It only ships 10% and 30%, so that means I'm going to get a 10% and a 30%, so those are the two that I'm mixing together. Okay, in the end I need the 10 liters of the 15%, so here's what I have at the end. So how many liters? So it's asking me for these two numbers. Okay, you can actually solve this in two different ways. Okay, I can think in terms of, well, I need two things, so I'm just going to call this one X and this one Y. Okay, if I solve it in this method, I'm going to end up using a system of equations because I'm going to end up with two equations and two unknowns. Okay, your other option is if you don't like doing two equations, you actually can do this in one equation, and it makes no difference what you were doing. When we get over to the calculator, I'll actually solve it in both ways. Okay, so here's, if I call this X, I know I need 10 liters altogether. So how much of this one do I have if I know I've used X liters of these 10 liters already? Okay, so just for a simple example, let's say this one I use 3 liters of. So this one I'd have to use 7, just because you know that together they have to add to give you 10. Okay, so I can actually just say, well, this then has to be 10 minus the X. Okay. Again, it doesn't matter if you do this in two variables, and that's the red with the X and the Y, or in one variable with the X and the 10 minus the X. Okay, so now we need to write our either one or two equations. So first let's write the one equation. The two equations. I'll go back to the red because that's what we talked about here first. Okay, back if you remember in the very opening questions we talked about how can you tell how much of it is an antifreeze if you know how much you have altogether and the percent that's antifreeze, and I just multiplied the amount that you had. Okay, so over here I had this is the amount that you have, so, and this is the percent of it that you have, and that gives me the total number of, in this case, gallons. Okay, in my case it will be liters. Okay, so this is just for one part, so I can use that same idea down here. Okay, so for the first one it's 10% and I have X liters. So if I multiply these two things together, it's going to tell me the number of liters that I have that's 10%. So if I take the 10% and I multiply it by X, okay, this tells me this is the number of liters that's at 10%. Okay, same thing, if I multiply these together, so if I take that 30% and multiply it by how many liters I have of it, this is the number of liters, I actually should say of acid, that would be in that mixture. Number of liters of acid in the 30% mixture. Same thing idea, this is actually the number of liters of acid in the 10% mixture. Okay, so if you add these two things together, right, the number of liters of acid in the 10% solution plus the number of liters of acids in the 30% solution, that actually would have to give you the number of liters of acid in the once you mix them together. Okay, it's conservation of matter in this case. So number of liters of acid in the 10 liters that I have all together. So same idea, if I have 10 liters and it's 15% acid, that would be the 10 liters I have times the percent that I have. So that would be the number of liters of acid that I need altogether. Okay, so remember I have two variables, so I have to have two equations. So that's the first equation, where it relates the number of liters of acid in each of the two barrels has to be the number of liters of acid once you combine them together. Okay, so again, if you think about this as like the conservation of matter, I can't lose anything when I go from here to here, put them together into here. It has to be the same amount of, like everything. So it's the same amount of acid, the same amount of all the other materials that are in there. Remember, this is 10% acid, so it's 90% something else. I don't know what that something else is, but okay. So all together I have to have the same amount also. So that means my other equation here would be x plus y has to equal 10. So the total amount of mixture altogether plus in the 10%, the total amount altogether, all 100% of it, plus all 100% of the 30% acid solution has to be the total amount I want to end up altogether. Okay, so here's my two equations that I have. Okay, so now let's next set up the one with the one variable, and then we'll go over and look at using your calculator for this. Okay, so for the one variable, the idea works the same idea. Okay, so I still have the number of liters of acid I have in the 10% solution is 0.1x, plus the number of liters of acid I have in the 30% solution is 0.3, and now instead of saying y, I want to write this as 10 minus x. Okay, and that has to equal the number of liters of acid I have in the entire mixture. Okay, so next we're going to go over to the calculator, and in the calculator part I'll show you how to do it in the calculator, both methods, both using the matrices and using your solver. Okay, so currently I'm using one of the color calculators. This works the same whether you have a TI-84 color one, just a regular TI-84 that's not color, or a TI-83. It will all be the same. So we're just going to do second and then the matrix button, which is on the button below the math button. Okay, so it says x to the negative first exponent button. Okay, and so then that brings up my matrix menu. And then the first thing we need to do is edit it, so I'm just going to move over to the edit menu. Okay, so now I should be sitting on the edit menu, and I'm going to press enter. I have a I have two equations and two variables. Okay, so that gives me a 2 by 3 system. Okay, so that should say, if it's nothing typed in yet, you want to make it 2 by 3. And now I need to enter my coefficients. So for the x's, it'll be 0.1. And then do it. Okay. And press enter after you enter the 0.1. Okay, and then in the next entry, it's going to be 0.3. And then again, press enter. And then the last one, I can do the multiplication just right here in this screen. So it's 10 times 0.15. And then again, press enter. I'll do the calculations for me. Okay. One thing I forgot to mention is make sure your equation's in the correct format. Right? All the x's have to be in a row here, and then the y's, and then it has to be equal to the number that we have over here. Okay, and then when I press enter, that gives me the 1.5. And then the last row, since the coefficient is understood to be a 1, remember we don't write it, so it's going to be 1, and then 1, and then the last number will be the 10, because remember we need 10 liters altogether in the end. Okay, so this is what my matrix should look like when you're done. Okay, so now do second quit, and the quit's right next to the second button on the mode button. Okay. And then we're going to go back into the matrix button, matrix menu. And this time we want to do some math with it, so move over to math. Okay, and it's actually letter B that we're looking for, so you can just press the alpha and the B key, which is on the apps button, or actually scroll down to it just to make sure you recognize which one it is. Okay, if you remember in class, I always say B for Beth. Okay. So we're sitting on B, or again, you can just do alpha B, press enter, or if you did alpha B, it automatically writes it over to your screen. Okay, and now you got to tell it which matrix you want to do this with. So I'm going to go back into the matrix menu again, so second matrix. Okay, now I stay on names because I just want to pick out the name, and we put that in matrix A, so press enter. Okay, end parentheses when you get back to the other screen. And then press enter one more time for it to actually calculate it. Okay, so that'll give me 7.5 for the amount of 10% and 2.5, this is on liters, for the amount of the 30%. Okay, so rather than use your variables, we're actually going to say 7.5 liters of the 10% solution, and then we need 2.5 liters of the 30%. Okay, so now let's go over and look at it using the one equation there, and I actually do it both on a TI-84 color, which looks different than the TI-83 or a TI-84 that's not color. Okay, so again, I'm on the TI-84, so to get to the solver, you're going to press the math button. Okay, and then I'm going to hit the up arrow button. And remember, the solver is the very last thing in the list. So then once you get to the solver, press enter. It's actually alpha B also. So, okay, in the top box, you put in the left-hand side of the equation. In the bottom box, I put in the right-hand side. So 0.1, the 0 doesn't matter when you're doing this because 0.1 and 0.10 is the same to the calculator. Okay, if it makes it looks like what I have in my equation, I can put the 0 on it. Okay, so 0.10x plus 0.30 parentheses 10 minus x. Oops, hang on, my calculator didn't recognize a couple of my keystrokes here. Again, I think my issues I'm having is with being hooked up to the computer. So 10 minus x end parentheses. Okay, so that's the left-hand side. Press enter, so it'll take you down to the next box. Oops, hang on one second. Okay, clear what's in that one, and then you're going to do 0.15, and then times 10. Okay, now you can either press enter again, or you can just press the OK that's there at on the graph button or F5 button. Okay, and that takes me to where I can solve it. Okay, if you have a reasonable guess, you could do that, and I actually could come out with a reasonable guess because I'm looking for 10 liters. So I know that, remember X is how many liters of the 10% I'm using. I know it has to be less than 10 as an answer. Okay, my two solutions are 10% and 30%, but 15% is closer to the 10% I have here. So I actually know I have to use more of this 10% than I do of the 30%. If this number would have been 25%, it's closer to 30, and I would have to use more of the 30. So you actually can do some reasoning here to figure out your answer. So I know this answer here is actually more than 5 even. And if you remember the answer we had before, 7.5. So if you wanted to make a guess, you could just guess 5, and that would be if you use the same amount of both. But you know your answer has to come out to be more than 5. Press second and solve, which is on the enter key. Okay. And somehow I got an error message. So let's go back to my error message. I'm just going to go to the go to. Okay, so my calculator responds. Go to. Okay, go up. And if you notice, I forgot my plus sign in the box. So I'm just going to press the up arrow button. Takes me back to here. Press it again. Sometimes it's good for me to make mistakes, I think, so you guys can see how to fix them. I want to move over so I'm sitting on the decimal point because I want to insert a plus sign in front of that. So I'm just going to hit the second button. The insert is on the DEL or delete key, which is right next to your left arrow key. So press it. We actually want to insert. That's why I press the second button first. The way your cursor flashes changes. Put a plus 3. And I start typing too fast. Press OK. Okay, and now do alpha solve again. Okay, now I have 7.5 out. Okay, so when I do it this way, now that I have the 7.5, I now have to go back over here and do 10 minus 7.5. Okay, so 10 minus the 7.5, and then that's the 2.5. Okay, so I'm actually getting the exact same answers that I got out when I did it with 2 equations. Okay, so again, you should write a statement that looks like this. Okay, so now let me go back over and we'll do it on the regular TI-84. That's not color. On the regular TI-84, the one thing you have to remember is you have to have your equation set equal to 0 to start with. Okay, so all I need to do is subtract this from the other side. So kind of in a way, all I'm going to do is we're going to get rid of the equal sign, take that to the other side, make that a minus, and then the whole thing is equal to 0. Okay, so that's what the equation looks like that I have to type into my calculator. Okay, so here, same idea. You go to the math menu. I'm just going to press the up arrow button because, again, it's the last thing in the menu. And again, it's under solver. Press enter. Okay, here's my equation equal to 0. So I'm just going to type in what I have down here. So 0.10x plus 0.30 parentheses 10 minus x end parentheses minus, if you remember in class a lot of times I said always put the other side in parentheses. In this case it's only one term so it's optional. 0.15 times 10 end parentheses. They have the equal 0 right here in it already, so you don't have to worry about the equal 0 part. It's already in there. It's always at the very beginning. Okay, press enter. Same idea on this one. You know that your answer is somewhere between 0 and 10, but it should be closer to 10 than it is, but we're just guess 5. Do alpha and then the solve button, and there's my 7.5. Okay, so the main difference between the two calculators and the solver is on the not color one, you have to have it set equal to 0. On the color one, it actually gives you the 2 boxes. Okay, so now it's your turn to try a question. So let's go over here to the next page. It says, how many ounces of pure water must be added to 50 ounces of a 15% saline solution to make a saline solution that's 10% salt? Okay, saline, hopefully you remember, is related to salt. Okay, so the first idea in these problems is set up what I call your barrels. Okay, so I kind of have choices here for you barrels just to help you out. So here's my choices on my barrels. Okay, so think about what I'm giving you and what you're trying to figure out. Okay, so now you should be able to answer the question in terms of which barrel, which set of barrels here is actually the correct answer for at least setting up the barrels. Don't solve it. All you're doing is looking out at which of these is the correct answer for the barrels. Okay, so now that you did that, hopefully you found out that the answer is A. So how many ounces of pure water? So this is what we're adding here, and it's ounces of pure water, right? Which means over here, remember I wrote the percent of salt, so it's 0% salt. Okay, and we're asking how many ounces of it, so I don't know, so that's why I put the X there. Okay, it has to be added to 50 ounces of something that's 15% salt. So this is what I'm starting with. Here's the water I'm adding that's 0% salt, and you want to end up with a mixture that's 10% salt. Okay, how much do we have when we get done? I have this 50 plus the X ounces of water, or 50 plus X. If you try to do this in two variables and you made this 50, this X, you could have made this a Y. Okay, so when we get to the next slide about what equation am I going to use, I did it in one variable, but you actually could do it in two variables, and we'll talk about that in the next part. Okay, so the next question is, once you have that set up as just one variable, I want you to give the equation that represents this situation. So I'm kind of taking you step by step how you should solve the problem. Okay, so answer the next question looking at this barrel setup that I have. What equation does that generate? Okay, so now that we're back, right, you should see that it generated this equation. Okay, so how did I get that? So again, if you multiply the 15% times the 50, that tells you the number of ounces of salt you have in this situation here. This, I have no salt in, so if you didn't even write the 0, you were okay with that, right? And then over here, right, how much salt do I have? And if I have 50 plus X ounces, again, I'm just going to multiply the 0.10 times 50 plus X, okay? And then that's how I got that equation. Okay. Now, if you did do it in two variables, I'll write that over here, okay, I would still start out the same idea. Okay, so in the first one, how many ounces of salt do I have? Well, I have the 0.15 times 50, okay, plus the number of ounces of salt that I have in water, which is just 0, or 0x, equals the amount of salt I have in the end, which is 0.10. In this case, I'm just doing two variables, so we'll call it y. Okay, now, remember if I have two variables, I have to have two equations. So what's my other equation? Well, it just means the total amount of mixture has to be the same all the way across. So 50 plus the X has to equal the Y. Okay. Now, again, if you're going to do this in two variables, remember this does not in the correct format. Okay, so my correct format would be I have to have the x's first, so working with the first equation that gives me 0x, then the y term, so I got to subtract it to get it over to the other side, and then equals your number, and again, you're going to have to subtract it to get it over to the other side. Again, I never do these calculations here until the end. I even just have them doing right within the solver or within the matrices. Okay, now I got to set this up in the correct format also, so it'll be x, and then minus y when I move the y over, and I got to move the 50 over, so negative 50. Okay, so my next question here is you're just going to have to solve this. If you're doing two variables, you now want to look at this set of equations that we just rewrote. If you're doing one variable, you're going to solve this. Again, I don't care which way you do this, okay, and even you can use your solver. So just solve that equation and give me an answer. Okay, hopefully you got the answer of 25 ounces either way you did it. I'm not going to go back to my calculator to solve this since I showed you how to solve the first one in the solver or the matrices. We should be good in terms of the rest of these. You should just be able to solve on your solver or in your matrices. Okay, so let's look at the next question. Okay, so a builder makes a certain type of concrete by mixing together 1 part Portland cement made from lime or clay, 3 parts sand, and 5 parts crushed stone. Okay, if you need 765 cubic feet of concrete are needed, how many cubic feet of each ingredient does he need? Okay, if you notice, this is a little bit different because I'm not actually giving you percentages. I'm telling you what parts of things you need. Other situations when this comes into use is sometimes when you mix your gas and your oil together to run like a chainsaw or a weed whacker or those type of things that take a mixture of gas and oil together. Usually it's the same idea. It tells you like 1 part oil to 9 parts gas. I don't know exactly what would be a reasonable thing to use there, but okay, but it's the same idea. So it's still a mixture problem, but it's not the same type of mixture problem that we've been doing. Okay, so I'm going to do the same thing idea though. I can still use these barrels. Okay, I have cement and it's 1 part. I have 3 parts sand and 5 parts. Okay, so out here on the edge, right, remember we're making concrete, and this is the parts of cement I need, the parts of sand, and the parts of stone. And this is over here is the amount that you're going to be using, right, on this line here. Okay, so if I use X cubic feet of cement, since I need 3 parts of sand, remember this represents 1 part, I would be using 3X cubic feet of sand. Okay, again, back to the fact that 1 part is X cubic feet, so 5 parts is 5X cubic feet. Okay, altogether though, remember here's my total. Altogether I need 765 cubic feet. Okay, so that's how I would set the barrels up for this. Again, I don't have percentages. I just have what parts I need of each. Okay, so the next question is, what would your equation look like for this situation? Okay, so now you're back, you answered that question, and hopefully you just see, well, you add up how many cubic feet you have of each of the 3 ingredients, and it has to equal the number of cubic feet you have altogether. Again, think about what this term represents. X is the number of cubic feet of cement I'm adding. 3X is the number of cubic feet of sand I'm adding. 5X is the number of cubic feet of stone I'm adding. All goes back to the 3 things individually that I'm mixing together has to be the same as once they're all mixed together. That conservation of mass. Okay, so that's the equation you should have been using for this problem. And then the next question is, I want you to actually solve that equation. Okay, so when you come out on this problem, when you're done solving it, don't forget, hopefully you actually had the boxes to do this, but if you're doing this, then it doesn't tell you, like on a test or something, and you got to make sure you give answers to all 3 parts. So I need 85 cubic feet of cement. How did I get 255 for sand? Well, if I need 85 cubic feet of cement, I'm just going to multiply that number by 3. So this is actually just 3 times that 85. Okay, so 3 times 85, right? And that's 255. And this one is the 5 times the 85 to get me to the fact that I need 425 cubic feet of stone. Next few questions. I'm just going to get you started, and then you're going to go over and actually finish solving them yourself. Your numbers will be different than my numbers. Just think about how to solve it with your numbers. Okay, so how many kilograms of nickel silver alloy containing 18% zinc, and how many kilograms of nickel silver alloy containing 31% zinc must be melted together to produce 706 kilograms of a new nickel silver alloy containing 22% zinc? Again, we're just going to be drawing barrels. So here's my first barrel. Just going to do a really rough sketch here. So that's the first one. So how many kilograms of this 18% zinc should I put in? So on the first barrel, we're just going to have 18%. And this actually over here, I'm going to say is the percent zinc. Okay. Sometimes it's useful to write this because you see eventually we're going to have some problems that will have 2 percentages of 2 different items, okay, and then you also are going to have an amount over down here. Okay, we don't know how many kilograms, so at this point you could actually fill this box in with X. I'm adding to it another mixture. Okay, so here's my barrel, and it's 31% zinc. So again, the 31% I'm just going to throw on top here. Okay, what do we want to end up with? We're talking a second about what you can put there. Okay, well, I end up with mixing these 2 things together, and what do I end up with? 706 kilograms, so that'll go on the bottom, and it contains 22% zinc. Okay, now the question is, what do you want to put here? Well, that all depends on if you want to do it in 1 or 2 variables. So we actually have 2 choices. If I'm going to do it in 1 variable, okay, that means if I use X kilograms here, and I have 706 altogether, then this number would be 706 minus X. Because I've already used X kilograms, I need 706. How much do I have left? If you want to do it in just in 2 variables, the red is 1 variable. Instead of using 706 here, I would just throw in this extra variable Y. How much of this do I need? How much of this one do I need? Okay. Okay, so at this point, you should be able to go through and finish solving it. Again, I have it mostly set up for you as far as the barrels. You need to translate this into writing an equation. So your next step would be to write the equation. Okay, and then you need to solve that equation. Okay, now you might be writing two equations also. So it depends on how you're going to do this. You write it with one equation using the 706 minus x, or am I going to use two equations using x and then the y? Okay, remember, when you're writing your equation, what you're actually doing is you're finding how many kilograms of zinc is in each of these barrels, and you have to have conservation of matter. Okay, so you should at this point be able to solve the next question. Okay, for this one, so you have a vat contains 4,110 liters of wine with an alcohol content of 10%. How much of this wine must be removed so that when it is replaced with wine with a 17% alcohol content, the alcohol content in the final mixture will be 12%. First, make sure we understand what's actually happening here, right? So we have a vat that just has wine in it. Okay, so again, I'm just going to make it my vat here with wine, and it's telling me the alcohol content. So this is the percent of alcohol. Oops. Okay, and this is 10% alcohol. We know it contains 4,110 liters. So again, this is just my amount, or the number of liters, however you want to do this. Okay, what are we doing with this? Well, here's a key word, this word removed. So we have wine that's being removed. So instead of a plus sign here, I'm actually going to do a minus sign. So I have this same wine. Here, don't forget, it's the exact same wine. So what's the alcohol content of this wine that's being removed? It's the exact same wine. It has to be 10% here also. Okay, so if it's the same wine, we're just taking some of it out. It has to have the same alcohol content. Do we know how much is getting taken out? No, that's my question right here. How much of this wine? So that's what I'm taking out. So we're just going to say we're taking out X liters of it. Okay, the next part we're talking about it being replaced. Okay, so getting replaced with wine that's 17%. So you notice I'm actually going to do a plus here. So far, a lot of the problems we've had, I've only had like these two barrels added together gives me a third one. Okay, but in this case, I'm going to end up, I start with something, I take some of it out, I'm replacing what I took out. Okay, and now I'm replacing it with 17% alcohol. Okay. How much of this am I putting in? I removed this. I'm replacing it, which means whatever I took out, that's exactly what I'm putting back in. So that'll just be another X there. These are the exact same amounts. Whatever you took out is the exact same as what you're putting back in. Okay, so now what I'm going to end up with, okay, so I have this barrel that I end up with, and it tells me what I end up with. We want a mixture that's 12%. Okay. Okay, so 12%, how much do I have? Well, you actually can figure this out. I started with 4,110, I take some out, I put the exact same amount in, I have to have back here what I started with, right? Or if you think of it as x minus x plus x, it gives you 4,110. Okay. There's no reason to try to do this one in two variables. For the most part, it's just a one variable problem because what you take out is the exact same thing as what you're putting in. These two numbers are equal. Okay, so at this point, all you need to do is, again, you're just going to write your equation, and then you're going to solve that equation. And again, the equation you write is how much of this 410 liters, how much of it is alcohol. Okay, so how do I find that? I'm going to multiply my two numbers together. Okay, so you can go ahead and solve your version. Again, make sure you realize you have different numbers, so make sure you work with your numbers, not with my numbers. The next question says this is a little bit similar to one we've already talked about when we added water to something. Okay, I can't remember exactly what the situation was. So how much water should be added to 1 gallon of pure antifreeze to obtain a solution that's 60% antifreeze? In this case, I already have this barrel set up. You need to tell me what R is, what W is, and again, we have this A, B, and T over there. So when you look at your next question, remember these are representing the percent of antifreeze that you have. So you just got to tell me what some of these variables represent. And then once you do that, you should actually then be able to solve it. Okay. Okay, so let's look at a potting mixture containing 12% peat moss and 6% vermiculite. This is where I was talking about sometimes you're giving a mixture, you're giving how much of it is for two different ingredients. But don't forget, it's 12% peat moss, 6% vermiculite. That only makes up 18% of the entire mixture. The rest of it is something else that we don't really care about. Okay, most part, like potting mixture is either some kind of soil or filler material. Okay, but all we care about is the peat moss and the vermiculite. So how much peat and how much vermiculite must be added to 100 pounds of this mixture to produce a new mixture having 15% peat and 15% vermiculite. So we're starting out with a mixture. I'm adding some peat moss, I'm adding some vermiculite, and I end up with another mixture. Now, how many barrels do I have? Well, I got the one I started with. I have the peat that I'm adding and the vermiculite that I'm adding. Okay, so I actually have, here's my mixture I'm starting with, plus the peat moss, plus the vermiculite, which hopefully I'm pronouncing that correctly. And I want to end up with this mixture that's those three things added together. Okay, so you notice I have two percentages. So we actually need the percent of peat over here and the percent of vermiculite. So this is the case, I can't have room to write the whole thing, and then the amount. This is a case of I need three things on each barrel instead of just two like I've been doing in all the other problems. Okay, so I'm starting out with 12% here, and then 6%. And if you keep on reading, it says how much peat and vermiculite must be added to 100 pounds of this. So I actually even know that this is 100 right here. Okay, so this is the peat moss that we're adding. So sometimes it helps to label things up here, what you're doing, and the other. Okay, and this is the original. So what percent of peat moss is peat moss? And what percent of peat moss is vermiculite? So this is actually 100% peat moss. 0% of it is vermiculite. So I'm not going to fill it on here. From here, you should be able to figure out what you need to put on this box, okay? And then I will fill the numbers in here because they're given to you. It's 15% of each of them. So I'll put 15% here, 15% here. Okay? Now we need to know how much of this one I'm putting in. I'm actually going to call it P, so I can keep track of that it's peat moss. How much of this one? Again, you should be able to fill in what goes on this barrel and this one based on what I put here. What do I end up with? Okay, well, I actually could solve this equation in two variables. If I do, I'm going to have to do a lot of working with it in order to get it into the correct form to put it in my matrices in my calculator. So I found that the easier way to do this is actually call this another variable. Okay, so I could call it 100 plus P plus V, but again, there's a lot more algebra you have to do in order to get into your calculator. Instead, I'm just going to call it T for the total. And now you should be able to set up actually three equations in this one. Okay, if you look at it, if you think about it, the first equation is the amount of peat moss I have in this one, plus the amount of peat moss that's in this one, plus the amount of peat moss that's in this one, has to equal the amount of peat moss that's in the final barrel that I have. That's your first equation. So the first equation says that the amount of peat moss has to stay consistent. Okay. The next equation, you're going to do the same idea, except now the amount of vermiculite that you have has to remain the same between the three barrels that you're adding together and the one barrel over here on this side. That's the total. Okay. And then what's the last equation? Well, the total amount all has to stay consistent also. So the last equation we'll talk about total amount. So I have 100, I forgot what units I was in. 100 pounds. I have 100 pounds of the original mixture. I have P pounds of peat moss, V pounds of vermiculite. I end up with T pounds of the whole mixture together. Okay, so once you write your three equations, you then are actually also going to have to go through and rearrange these because your equations should all be in the form of P, your V, your T, and then the equals your number. Okay? So you're going to have adding or subtracting here. And actually, if I help you a little bit here, the last equation, your last equation would be 100 plus P plus V equals T, but that's not in the right form. The T has to come to this side, and the 100 has to go to that side. So the equation here that you'd actually be working with would be P plus V minus T equals negative 100. So that's actually the last equation that you'd be working with, would be this one right here. Okay. Next question. So how many tons of tin must be added to 2.75 tons of bronze to raise the percentage of tin from 10.5% to 16%? Okay, so one thing you have to realize here is bronze is a combination of copper and tin together, okay? So, but what we're interested in is raising the content of the tin, so I don't care anything really about the copper. Okay, but think back to, I'm actually adding pure tin, so I'm not even going to set the barrels up on this one. All right, so think about how many tons of tin. So on one barrel, you're adding just directly tin. So how much tin is in tin? Okay, the other barrel, you have 2.75 tons of bronze, okay, and it's 10.5%. In the end, you want 16% of it to be tin. So I rewrite right what I said here. So the 2.75 tons of bronze is 10.5% tin. You want to end up with 16% tin. Okay, so at this point, you should actually be able to write your equation for here. Don't forget, you're adding tin. What percent of tin is tin? Okay. Oops, one more. Sorry, missed it. Okay, so same idea on this one. So from 12.5 liters of coolant containing 13.4% antifreeze, 5.5 liters are removed and replaced with pure antifreeze. How many liters of antifreeze will be contained in the final mixture? Think about this problem. It's very similar to one of the other questions I already have. I start out with a coolant, right? I know the percent of antifreeze in it. I have some that I'm removing. I'm then replacing it, right? So then the little difference is I'm not asking you for a percent or something. I want how many liters of antifreeze, not how many liters of the final mixture do I have, but of the final mixture, how many liters of it is antifreeze. Okay, so this is similar in setup to one of the other questions. I am asking a little bit different question than I did over in that one, but you should be able to set this up based on how I did the other problem that's similar, and then able to solve for what they're looking for.